All right, so for question number 2, it says there's a 6.3 kilogram. Can somebody get the door for me? Kilogram mass attached to a string that's whirled in a horizontal circle with a radius of 48 centimeters. Okay. If the string has a breaking strength of 910 newtons, what is the maximum speed at which the mass can be whirled around before the string breaks? All right, so let's draw the picture first. All right, so I've got some object. It's like this. And here's Mr. Adams. And I've got my arm. And then I'm swirling this object around. And this is totally not proportional. So let me make it a little more proportional. So here's Mr. Adams. Here's my arm. Here's my other arm. I'm really tall. Okay. And I'm swirling this thing around, and it's going around in a circular path. Like that. And it says that the radius is 48 centimeters. But how do I have to rewrite that? What do I have to convert that to for the physics to work? Can I leave it at centimeters? No. I got to do what? Convert it to meters. So remember that 48 centimeters is the same as 0.48 meters, right? So 48 centimeters equals 0.48 meters. Okay, you just move the decimal over 2 spaces, 1, 2. All right, and the mass of this thing, M for mass, is equal to 6.3 kilograms. All right, well that's good because it needs to be in kilograms. And then it has a tension of 910 newtons. Newtons is a measure of what? Force. So newtons is a force that's needed. So we need to have, and let me rewrite this a little bit different. We need a force that's greater than 910 newtons, right? Does that make sense? All right. Is there any other information they give us? Now, if you were to do this on your own in your homework, this is where it's a little overwhelming. You might be like, where do I start? What do I plug in? How do I calculate this? Well, what you do is you look in your notes for an equation that has most of this stuff. Well, this is the maximum force. So this is a force. Then you look for something that has a mass. And then you look for something that has a radius. And this is the stuff we know. But then it says at the very end, what is the maximum speed? Well, speed's velocity. Okay? So what we have to do is find an equation that has velocity, force, mass, and radius. Now, the only difference between you and I is that I've memorized these formulas. You just have to look in your notes that we took yesterday and go, okay, is there a formula that has force and velocity and mass and radius? There is, okay? So somewhere in your notes, you've got this beauty. Force is equal to the mass times the velocity squared all over r. It's all right there. And I think this is the hard part about a physics class. But this works every time. And I'll be honest with you, I was taking physics for a whole semester before I discovered this. I would just look at all the equations and go, I don't know what to do. And one of my professors said, look, you just list what you know, list what you don't know. Find an equation that has all that stuff. All right. Well, what are they asking for? Well, they're asking me for v squared. Now, there's two ways you could do this. Or actually, they're asking for v. There's two ways to do this. I could start plugging in the numbers and solve for v, or I can algebraically solve for v first. I like to solve for v first. So what I would do is I go, okay, I've got to get v by itself. And then I just do algebra, right? All right, so I got to move some stuff away. To move the r away, since r is dividing v, to move it to the other side, I simply multiply both sides by r. These r's cancel, and then the next line would be f times r is equal to mv squared. So far, so good. Now I got to move the m away. Well, the m is multiplying times v, so I do the opposite of multiplication, which is division. I divide by m. Whatever I do on one side, I have to do on the other. Then I get fr over m is equal to v squared. Now, to undo this square, I have to take the square root, and whatever I do on one side, I have to do to the other, and I end up with v is equal to the square root of the force times the radius all over the mass. Now I just plug it in. 910 times 0.48 all over 6.3. And don't forget to take the square root of that. If I plug that in the calculator, it ends up being about 8.33 meters per second. Now, this is the same physics that's applied to like the rides you ride at a county fair or something. They do this math. The engineers that design those rides that whirl around, they do math like this. They know how strong the ride's going to be. They know that there's a maximum tension that'll pull the car right off the ride. And they just make sure they don't go above that speed. They also use another thing to make sure you don't fall out of it. And when they calculate all that stuff, they go, all right, this is how fast you have to go. You can't go faster than this. You can't go slower than this. Okay? That was a nice problem. I like that problem because it kind of reviewed some of the force stuff. Okay? Any questions on that? Was there anything that wasn't clear? Okay, good.